The disease spreads through small droplets that are expelled from the nose or mouth when a person with COVID-19 coughs or exhales. Therefore, standing close to someone who is infected can put you at risk. These droplets can land on your hand and be transmitted through something as simple as a handshake, if afterwards you touch your eyes, nose, or mouth, the so-called T-zone. The virus is known to survive on different types of surfaces, so touching these contaminated surfaces and then touching your T-zone brings a high risk of infection.
When the coronavirus attaches to a cell, it begins to replicate within the cell. The body's immune system attempts to destroy the virus, which results in an inflammatory response that causes fluid accumulation in the lungs. As the lungs fill with fluid, the body's available oxygen decreases, which can lead to organ injury and death. The risk of serious complications increases if a person is elderly or has associated medical conditions.
Standing there. Open Sesame!
Washing your hands with soap is possibly the simplest way to flush pathogens down the drain. Soap molecules can interact with pathogens, such as coronavirus, leading to their destruction. Each soap molecule has two parts. The head is hydrophilic, which means it likes to interact with water, while the lipid tail is hydrophobic, which means it wants to get away from water to find similar water-avoiding particles. This is the basis of how soap works. When soap molecules encounter lipid particles on our skin, the tails aggregate around them to form spherical structures called micelles, creating a water-free environment. Similar things happen when they encounter enveloped viruses such as coronavirus. Enveloped viruses carry their genome and supporting proteins inside a lipid bilayer membrane, with the proteins necessary for infection embedded in the membrane. In cells and viruses, these lipids are packed neatly into two sheets with the lipid tails facing inward. The lipid ends of the soap molecules are attracted to the lipids in the membrane. They take advantage of the presence of membrane proteins which can perturb the neatly organized bilayer to insert themselves into the viral membrane. If there is only a small amount of soap, the soap molecules only loosen the membrane. But with more soap, they begin to create micelles around membrane lipids. They are also attracted to hydrophobic amino acids in the membrane proteins, extracting them from the membrane. The structural integrity of a virus is essential for infection. So, washing your hands with soap protects you better from infection than washing with only water.
It is spread from person to person, mainly through the droplets produced when an infected person speaks, coughs, or sneezes. These droplets can land in the mouths or noses of people who are nearby. These droplets are too heavy to travel far in the air. They only travel approximately 1 meter and quickly settle on surfaces. This is the reason person-to-person spread is happening mainly between close